think it is time for a video. I think, I would like to show you my 6 AC cooling system on Venus. Yeah. And I would like to show you how you can set it up, how you can use it, and what is the capacity for the cooling. Right now you can see this is 6,000, let's say 6,600 joule for the current temperature, and it's cooling this pipe, as you can see here, and this pipe is connected to the room. But what I would like to show you is just how to set it up, and maybe you want to play around with it, and yeah, let's see how it goes. So first we need some atmospherics right here. Let's grab the auto. Alright, so the system starts with you set up 6 air conditioners with one space between each. Of course you can set it up how you want, but it is important that you have one space between each air conditioner. Yeah? So, no, wrong direction. So, come on. Yeah. Okay. So let's try this again. As you can see, so let's connect it right away with some pipes. Pipe here, pipe here, pipe here, and pipe here. So this is the basic layout. So far so good. Now, and this is the important part, hang on, we still have the pipes. Now you connect the waste from the second one to the last one, and you connect the waste from the third one to the fifth one. Okay. Yeah. Not sure what I'm doing here. I'm looking for a T. Alright. So, as you can see, these two are connected and these two are connected with the waste pipe. Now we need some regulators. The regulator goes in this direction for both. Now we need some passive vents. And some passive vents. And let's have here a valve, just for the heck of it. A valve, and yeah, let's connect it. I mean, here on this side you get some hot gases. You can use this pretty much for your furnace or for whatever you want, maybe for the Stirling later. For now I'm just collecting it. So let's connect it right away here. Dip, 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 and as you can see, I already have one running, and this is no problem to hang on, I think this, yeah. It is no problem to add another one, I wanted to say. Yeah, obviously, like usual, I'm not the right guy to explain things, but I hope you catch my drift, and maybe you find it interesting and try to play around with it. It is it is a really easy to set up, and yeah. But as usual, the detail makes it a little bit difficult. So we need a pump at the beginning of the chain. Yeah. So you have a pump, and we connect the pipe to our feeding system. as you can see here. So this feeding system is a filtration unit, and the filtration unit filters with this contraption here. It filters N2 out of the atmosphere. As you can see on Venus, we have N2, we have CO2, and we have X. What we want is N2 for this cooling system. So this machine fills this pipe, and as you can see here, this pump controls how much NO2 comes from here to here. And yeah, this is pretty much it. What you need is an analyzer. That's a start. Hang on. Yeah. Wrong. So you need an analyzer. So the calculation is made by this AC. It controls this pump, how much this pump will pump each tick in this pipe. And to control the pipe, you need the pressure in this pipe, and you get it from the pipe analyzer. All right, so this is pretty much it. So let's connect the whole thing to the power network, as you can see here. And like I said, you can build it like you want. I found this is a very compact way to build it, and the only constraint is to have one pipe between each other. This is the only constraint. It doesn't matter. It doesn't matter how much, how long your connection between the waste is. And yeah. So anything else? So far so good, I think. We missed one here, and we missed one here and here. So as you can see, now is everything connected to the network. Let's have a transformer here and connect it to the main power network. And give it some connection to the network here. No. Yeah. Okie dokie. Easy does it. Okie dokie. So now we have to turn this thing on, of course, and we give it, I don't know, 3000. The whole system uses without the display 2100 watts, and it is running continuously. So make sure that your main power can provide 2100 watts for the main system. Okie dokie. So this is pretty much it. Let's turn you on. And for the configuration, you have to set up this thing. I'm using hang on. Let's start with this thing. So this is a control for the AC, and this is the only control you need. And let's import it here, and let's bring it back. So happy. Here we go, and let's make a new one. So let's make an integrated ship, and Yeah, this is pretty much what you can see here. It is a pipe analyzer. Also, so it needs a pipe analyzer. It needs a volume pump, and self is the air conditioner that controls the pump, this input pump. The whole program. I'm not sure if you are interested. I can give you the code, or you can make it yourself. This is how I made it. You can do. Um, yeah, you can try your own. That's what I wanted to say. What it does is it provides, it calculates the output for the volume pump. Yeah. So the volume pump, this is a calculation for the setting on the volume pump. As you can see here, this is the setting that is set on the pump, and this is a formula for it. And yeah, like I said, I'm not the best coding guy, if you want to call it. This is my approach. Try it. You can try it yourself. And I'm using a memory chip to provide the setting for it, so I can set the desired pressure on the volume pump. I can set it externally. This is the idea. So let's make this. For this we need a memory chip. And we bring the memory chip here online. Cable. And this is a memory chip. So at the memory chip you set the value to 133. Yeah? I'm explaining this number a little bit later. This is pretty much all you need. Hang on, we need another thing. I like to set up this. Hang on, we are still. Oh, bloody hell! Go away. Hang on. Go away. Integrated chip, of course. Alright. So for this we need a quick setup chip. We set to itself the setting, and the setting we set to 1220.15. Confirm export, and now we can. It saves a little bit on the clicking on the machine, as you can see. So what you do is these three machines, you turn it on. You give it your setting, yeah? And as you can see, this is set to 999,999. Yeah, and this is the same machine. As you can see, now it's setting to. Of course, you can try to do it like this here, but this is not for me. So I'm setting it with the chip. Okie dokie. Here you forgot the pipe. Okay, let's make the pipe here. So this is your cooling pipe. This is where the gas which you want to have cooled is sitting. So okay, let's connect it to the room. As you can see, this pipe goes to my room or to your tank or to whatever you want, and it can have whatever gas you want to get cooled. It is not contaminated by the AC. Okie dokie. So we can set these here to minus. Yeah, maybe it's fast enough. So these three machines go to, you set the desired temperature to minus 270. And here we go. And this is pretty much it. Now you can start every machine. Yep, yep, yep. Here we have to set the screws. And I'm setting it to the pipe analyzer, and I'm setting it to the volume pump. As you can see, pipe analyzer, volume pump, pipe analyzer, volume pump. Okie dokie. So, and this is pretty much it. As you can see here, we have a lot of megapascals in the feeding pipe. We can have a look at the pump. The pump is not set. Are you alright? Yes, you are alright. Why is the pump not set? Pipe analyzer, volume pump. Pipe analyzer, volume pump. What is it? What is it what you want? Oh. Right, I didn't export the... Yeah. You can go away. Yeah, I didn't export the actual trip here. Okay, do we hang on? So let's try this again. And this is pretty much, yeah, the only thing is you have to find your own way, or you or you ask me for the code or whatever for the pipe feeding. Hang on. So let's actually export you. And let's bring it back. So you can have you, and you can have you. And now if you look at the, as you can see here, now the volume pump is set to 0.2 whatever, and this means with this setting it provides 100, this number here, 133 kilopascal to this pipe. As you can see, nice and easy. And this is pretty much the setting. So remember, cold, 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 hot, hot, hot. These machines are only set, and now we can start the system and it will cool our system. As you can see here, it will cool our system. To get this number, let's make a frame. No. Sort this out here a little bit. Okay, this was not good. Let's make it here. We need a console. Wrong. So I'm using a large one here. And let's give it like this and connect it to the network here. Hang on. We forgot something important. We forgot something important because right now it's not cooling. You set this regulators to 1 megapascal. As you can see here, 1 megapascal, and you turn it on. And as you can, yeah, no cables, right? Yeah. So of course you have to connect these things to the network. And now they fill this pipe with Venus atmosphere to 1 megapascal. Yeah. Same as here. Connected. And let's have a look. Yeah, as you can see, we have just normal atmosphere, and 1 megapascal is enough. And the same for here. As you can see, this one is already. After a while, you can these pipes get cooled down a little bit, and they have to feed a little bit more gas. So for the start, you can have this on. But after a while, you can turn these off and save a little bit energy. So let's try this again. Okay, dokie. So now we cool our system, and how much? So the capacity of the cooling system is defined by this machine. You can check it. You can check it without a display. If you have a look here, hang on. If you see these numbers here, so right now the temperature differential is a little bit too much, as you can see. So you multiply all three efficiencies, and you multiply it by 14k, 14,000 K, 14,000 joules. Yeah. So 14,000 times 99 times temperature differential 15, 16, 17, and times 49 pressure efficiency. It needs a little bit time to equalize, but it is really fast. So 3 minutes or so, and the system is stabilized. And after this, it is okie dokie. So I wanted to show you logic, of course. Give me some cables, and connect you. So this ship is is this ship, and it makes a calculation I mentioned earlier. So let's have a look here. Import. As you can see, it needs CAC. It needs an LED, so an output display, and self is not important. Here we have the 14,000. Hang on. Here we have the 14,000 joules, and here we read the pressure, operational, and temperature differential, and we multiply these three. This is all. This is yeah, what this code is doing. So confirm it. Let's have another integrated chip. This is not necessary for the AC system, but it is quite nice to have. So export. Now we have our displays. So let's give you back here, and give you back. Hang on, where are you? Yeah, I forgot the ship. Okie dokie, okie dokie. So give me the ship. And here we go. So of course we have to set the screws here. So the first one was, I'm very bad with remembering these. So the first one is the AC. So the AC is this one. Let's give it a name. AC 104. And so we can find it easier on the screws here. So let's have you AC104 and the LED. Right? So if we turn it on, no error, and this should display what we have. As you can see, right now the system is providing 4900 joule, which equalizes to 6 wall coolers or to to 6 wall heaters if you want it. So you can put 6 wall heaters in your room, and the AC can counter the heat of these. As you can see here, this is a little bit more equalized, it is a little bit better, and it also has a different setting here. Here I have 140, and here I have 133. So now I have doubled my cooling capacity for the room, and this is pretty much it. For what you use it, the application of the AC unit, this is entirely up to you. It is a continuous system. It provides the cooling constantly to whatever you have on the side. As you can see here, I have 24 degrees. Let's make this here a little bit more. Hang on. So give this 101.325, so 1 atmosphere, and so now it's night. The lights should go on in a second here. Yeah. So I'm in the process to bring this greenhouse here online, and right now the room is cooled with 6,500 joules from this block and 6,000 joules from this block, so 12,000 cooling capacity. This regulator pressurizes the room to 101 kilopascal, and it takes the hot N2 part from the atmosphere. And this is why you can see the cooling is still working, but because we introduce a lot of heat from the outside, you cannot see that it is cooling here. So it counter cools whatever comes from here. Not sure if this is well explained, but anyway. Let's have a look then. Yeah, this is pretty much it. I would like to give you a little bit more details about the technical side, but from here you can pretty much play around with the system. Let's make some light here, and let's have a look. So the system is defined by no, first let's look. I walk you through how it works. The volume pump provides a certain amount of kilopascal to this pipe. The first AC cools whatever comes from here and puts it here. The next one takes this one, cools it down, puts it here. The next one cools it down, takes it from here and puts it there. And this pipe, as you can see here, this is the defining temperature for your system. As you can see right now we have 39.14 degrees. This means whatever was coming from here with 464 degrees Celsius is cooled down to 40 degrees. Now, this AC is heating up whatever comes from here and puts the outside, so the heated, as you can see, it is hotter than the input. And in the process of doing it, it provides cooling to this pipe. This is a special property of the AC unit. If you have a cooling AC unit, the waste gets hotter, and if you're heating your gas, the waste gets cooler. And this is what I'm using here. Yeah. So this machine is heating up the gas that comes from here and puts the hot gas here. Now, like I said, the cooling AC is heating up this waste. Yeah? And what I'm doing is I'm giving the system another hot AC, and so this equalizes this pipe. This AC is putting hot heat into the pipe, and this AC is putting cold into the pipe. And this means this pipe is staying at the same temperature. Where is that? Here I have it. As you can see here, this pipe has 228 degrees, and it is stable. It's not getting hotter and it's not getting colder. And the same the same happens here. Yeah. The same happens here, because this cooling, this is heating the waste, and this AC is cooling the waste. And if you look at the efficiencies of the machines, they equalize each other out. Yeah? So 40, 46, 99, 100, and 45, 100, 100. So both machines provide the same heating and cooling, and this makes this an equilibrium. Right. So now you may ask, what is this number? If we change it to something, hang on. If we change it to something, let's say 150. This means more gas comes into the pipe. The AC cannot cool more gas. So let's try this again. So before we had 133. The AC takes it, gives a certain amount of joules, removes it, and puts it here. If you have more gas, the output temperature is higher. Yeah, so 150, the output temperature is higher. And if you remember, we had here something 6,000, and now let's have a look here. As you can see, now the temperature is 73 degrees. And this means the output temperature is hotter than the temperature before. So what this also means is, because this AC, hang on, this AC needs this waste temperature. If you start your system with 400 and something degrees, so you have a Venus atmosphere here, the difference between like this 400 and whatever is here, let's say you have set it to 40 degrees, is very high. So the difference between hot and waste is so high that the cooling is not very efficient. This means if you start your system with a very hot temperature, you set this number. Yeah. You set this number a little bit higher. Yeah. So not 133. You can try whatever you feel like. The minimum number for this is this. Don't ask me why. Hang on. I can explain it, but I don't want to. The minimum number you can set it to is this one. Now have a look. This means our efficiency drops very, 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 very low in this case, because this means this is the lowest amount of moles you can have here. And if you look here, there's not much moles coming on, coming to this side, and this means the pressure efficiency is 37%. Anything else is 100%, but the pressure efficiency is too low. This is, if we set it back to 133, or let's make it 121. Yeah, I think I had it here, 121. Hang on. No, 140. Okay. I think I want you to have 121. 121. Okay. So let's have a look here. As you can see, now we have 5390, and this is pretty much the sweet spot for the temperature I have set for the greenhouse. It can go up to 7000 if your room has 100 degrees. The machine will give you 7000 cooling capacity. But of course, it cools it down to your room temperature, and this is normally 0 to 30 degrees, and it stabilizes in this area. So 5000 something. Okie dokie. Yeah, I think this is it. Do you have any questions? I think I wanted to show you that it is possible to get a decent cooling out of 6 machines on Venus. The whole system with equalizing the waste is the key point here. So you have 3 ACs. The first takes the cooling from the atmosphere, and the next one's equalizing each other out. You can try to give it another line, so 2 more here and the cooling device here. This would make it a little bit, in theory, a little bit give it more cooling. But the problem is, let's say you put 2 moles here in this machine. Because it's colder, so each step makes it colder, and yeah, I'm not sure what I wanted to say. Yeah, okay, let's try this again. Let's say you have here 133 kilopascal. Because the gas gets cooled down, you have here 101 kilopascal. Yeah? Because it's colder gas has a lower pressure. This means the efficiency for this machine gets dropped. If you see here, 100%, and this has only 90%. So it is 101, and like I said, 111 is 100% pressure efficiency. Because we have 101, we have only 90%. And this, of course, the next one gets even colder, so even less. And this means we have now only 66 pressure efficiency. And this is pretty much the sweet spot. You can play around. If you change the number at the beginning, you can play around whatever you feel like, and you can see if the pressure efficiency is getting higher or not. The same for here. As you can see here, the pressure efficiency is roughly 40%. But the other numbers are 100% and 100%, so you get roughly 40% of 14,000 joules. Yeah, and if you put another line, you probably get a pressure efficiency here of yeah, maybe 30, 20, maybe less. Okie dokie. So if you have a question, feel free to ask. If you can make the system better. I leave it up to you as an exercise. You can make this a little bit better if you know how to code and if you're willing to put a lot of effort in the system. Yeah. But this is it for now. I hope you learned something. I made this mostly for myself, so I can remember, watch each part it is, and in a year or so I can come back and can see what I have done. But if you found it interesting, maybe it is for you as well. Yeah, this is my greenhouse. I don't know if anyone is interested in seeing how this works, or I could try to explain. The idea is to have winter spawn here, and the winter spawn provide cooling, and they should provide enough cooling to let a Stirling engine running full capacity. This is the idea. Of course, you can make a 3x3 greenhouse, put it full of winter spawn, and you have enough cooling for whatever you feel like. But this AC unit is very helpful. Not only is it helpful to help the cooling in your greenhouse, it is pretty much necessary to cool down the initial gas. You can have, as you can see here, I have here iron walls. Yeah, iron walls, and on Venus this is not a good idea in general, but because you have the cooling, you can just cool the initial atmosphere in the room, and you use your AC. And if you have it running, well, you can leave it there, and it is working. The Stirling engine provides 8,000 kilowatt. One block needs 2,000 kilowatt, so 4,000 kilowatt if you use two. A couple of other machines, roughly 3,000 kilowatt. So you have a net 5,000 kilowatt from the Stirling engine. Anyway, enough talking. Like I said, if you have a question, feel free to ask. Otherwise, have a good day and see you.